Pro 8 DevOps moves. So this course is completely covering on the CD part and little bit on the CI part. Okay. As I mentioned in this title of the course and as well as uh, the course design, I mentioned some of the tools like Docker, Kubernetes, Terraform, and Grafana, Prometheus, and SRE techniques, AI techniques, and security operation techniques. I have mentioned all these things. So these tools are only focused on your CD platform of the DevOps, where it is completely enterprise level. All the experienced people who are facing issues on the CD platform side, you might be a build and release engineer, you might be a observability engineer, you might be a SRE engineer, or a DevOps associate engineer, or a DevOps engineer, automation engineer, or an infrastructure engineer. So these are common for everyone. It can be a GCP, Azure, or a AWS as well. So it will be a common. So these things I'll be going to cover in this course. And before, uh, since the many new people joined, let me introduce myself. I'm Rajinikanth Vadla, and I have entire 7+ years of experience in this IT market. Completely, I worked on product development and operations. Now I'm working as a AIML DevOps Ops engineer. So many people don't know what is this. So my focus is only on the development platform, like a developer. So make the developer life easy and also handling the operations. So this is what I do on the AML side. So we need operations as well and we need development experience as well. So this is something I'm doing from the last 5 years, and I also worked on many projects. I developed many products, and I am part of with big team, small team, individual, different types of experience I have collected, and that is what I'm now here to teach you. If you have any question about anything, you can ask me over the WhatsApp or you can ask me here in our class as well. Okay, let's continue with our demo 2 concepts. If I go to this syllabus, which I have given you the syllabus, yesterday I have covered some basics, a theory part, and I have mentioned some of the modules. If you see module 1, Docker deep dive in week 1, I have planned this in 12 to 13 weeks, basically. So in this module, I will be covering complete Docker, a basic level to high level, expert level, I would say. Expert level means what else we can do on the Docker part. Yes, there are many things. Some of the organizations are still using high level Docker structure, no? High level Docker structure they are using. So you don't know about that. We know only Docker file and Docker image building, and that's it. And we're deploying that through the Helm charts or a kube manifest files. It is not enough. The things which I have mentioned, which will give you the more experience on developing this Docker environment. Even it includes Docker Compose as well. Okay, it's a Compose also part of this module. Okay, module 1. Module 2 is about the Kubernetes essentials. It's almost going to take 2 to 3 weeks, as I said last time in the yesterday as well. So we will learn complete Minikube and Kubedium and cluster administrations and cluster maintenance, how we can do and what are the things that we can administrate in a secured way in a public and a private clusters, and what strategy we can develop the cluster and what strategy we can deploy the cluster with workloads. All these things I'll be going to cover in this part, okay, in this Kubernetes essential, where it is completely suitable for your CKA exam, Kubernetes administration exam, okay, CKA. That is module 2. And coming to module 3, Terraform and Cloud. I'll be showing you three clouds, but I'll choose one cloud. I'll choose one cloud. I'll choose one cloud like AWS, and then I'll show you complete Terraform workflow and the life cycle. But I'll also replicate same kind of things, one or two projects with the Azure and the GCP. So you'll be understanding by using Terraform how we can practice or how we can develop or provision the cloud infrastructure over the different three clouds by using Terraform. Okay, so that we will be going to cover completely. It is also going to take surely 12 to 15 days or maximum 12 to 13 days. So each day you can consider 1.5 hours. Okay. And CI/CD part, yes, CI/CD part where security operations also come into the picture in your Kubernetes and CI/CD and Terraform. So in these three tools, your security will come into the picture. So that's where we call it as a DevSecOps. Okay. So security operations on your continuous integration and deployment part and RBAC roles, role assignments, integrating the security setup over your Kubernetes cluster on the Terraform side. So these things I'll be going to cover on this part and GitOps and monitoring. So not only these tools, I'll be also covering with some other tools as well. So if I keep all the tools here, it will be bulky. So these you can consider those are nested under these points. And I will be going to cover project integrations. E-commerce shop fast is a project where it will give you a complete stack about your Python Postgres databases and container Kubernetes CI/CD GitOps and monitoring, where completely real world kind of project you can showcase in your GitHub profile or in LinkedIn profile. Track B, which is microservices and API platform, similar like your company project only by using Node.js, Java, MongoDB, and Redis. We use multi-service stateful set and Argo CD observability. So there are other components also going to involve here. So we will be going to develop this as like a same real-time project. And I will be also adding some more things. I'll also tell you that how the live data will be also fetching into your application site. So that will also I'm going to cover. So platform engineering. So there's a tool called Backstage. There's a tool called Flux. There's a tool called Argo CD. So there are internal development platform tools are there. Most of the people don't know. So that's where the platform engineering will come into the picture, where DevOps engineers also work as a development part in the platform engineering. So developer portal, self-service, SRE practices, these are comes under the platform engineering actually. So these projects is at least one project will take more than 4 hours of time, 4 to 5 hours of time to developing, implementing and deploying and monitoring and seeing the structure is working or not, kind of a smoke test. We are doing smoke test also on this project. We'll get a complete view what happened from the left to right. So this is my word that I will going to give you this complete three projects 100%. And the second phase is like AI and SRE. I'll be going to teach you some AI techniques in the DevOps, that how you can do troubleshooting with AI, intelligent alerting, code generations, performance optimizations by using AI, which you can add in your resume as well for your future job switching, which will help you good. And SRE practices, which is at the production level, SLO, SLI, error budget, capacity planning, incident management. This is not something only SRE specific focused only. This is something everyone should know. He should be or he or she should um, be a business analyst or he or he should be a developer or a tester, whatever. These things are mandatory. Everyone has to know this. So by this my course, you will get Docker Certified Associate Knowledge, CKA Knowledge, Terraform Associate Knowledge. So what I need from you guys, if you have these things, like the basic Linux commands knowledge, networking fundamental knowledge. You should have a GitHub account and at least one cloud. AWS, I would be preferring that. Okay, AWS cloud account and Docker desktop should be installed in your system. Otherwise, we can go with the other tools also. I will tell you Minikube tools like Kind and all. You can install those as well according to your system. Might be use Windows or a Mac. So Docker desktop will be support for it. And anytime you have any issues, you can ping me over the WhatsApp. So my mentor will be there and he or me will address your issue. And you'll get lifetime recording videos, access lifetime. Whenever you access, come back to the drive and access, you'll be finding the recording of this course. Documents like the notes and the cheat sheets. So all the command things and all you'll be getting in this Google Classroom. So where you can find? You can find over the Google Classroom. So this is a syllabus and yeah, if we get into the some kind of other details, every day it is 7 p.m. to 8:30 p.m. I know few students are in the like from UK, US and all, so they are not able to attend this session at this time. But who are watching this recording, so uh, I have already covered this for them. No problem. So 7 p.m. to 8:30 p.m. is the class, daily 1.5 hour. So we'll be going to cover more into practical, not into theory. Theory will be very less, like I would say 30 minutes, and then everything is a practical thing. And you can attend 1 week demo classes, which will give you good understanding at least. Not 3 days. 3 days will not give you good understanding. So go for a 1 week demos. Then you decide whether you should continue or not. And the course fee is 10K INR. So this is the basic information about this course, like 10K and this 1 week of demos, and this is the timing, and you'll get everything recording and notes, everything at your Google Classroom. Once you have enrolled this course, you will be getting an invite to join into the Google Classroom. Once you got an invite, if you join, you will find all the videos over there of this particular course. I would like to, without wasting a time, I would like to start topics, guys, because giving this generic information, everyone know that. So they can find from the syllabus, they can find from my the last class video, right? So, well, without wasting a time, let's start the some of the topics so that we can save our time in the future. So Docker, as I mentioned in the first module in the syllabus, Docker is my first thing to start. Why only Docker? Because from Docker itself or Ansible itself, the CD platform will be started. Containerization. So we need to understand what does mean by a containerization. So before we're going to talk about the Docker, because Docker comes under the containerization technology. Containerization technology actually. We industry companies, enterprise companies are facing some problems previously. So that's why Docker came into the picture and every company is adapted to the Docker. Means every company is adapted Docker technology and they have used it and still it is being used. Why? How? So what is the point? Why these companies are moved towards the Docker? We should know that. Then only we understand the importance of the Docker, right? If I go to our notes, so basically we have a virtualization concept previously. So there is hypervisor 1 and hypervisor 2. There are two things actually. Okay. And the hardware virtualization. In 2005, 2010, even before 2005 as well, in 2000s, in 1998 also, this freebies also there, the containerization technology. So 2005, around that time, so there is a VMware ESX or Microsoft Hyper-V Generation 1. So this is a technology that time were used for this servers to deploy the applications. It's completely bare metal server. Bare metal server means your physical server. Nothing is done. No software installations, no booting, nothing. It's a complete a server where you'll see a kind of a without operating system a laptop, a kind of server you're seeing over there. On top of that, you are maintaining, you're installing, you're configuring, and you're doing everything, and then the server is ready to deploy the things. It's completely a full hardware emulation. So like each VM, you need to run a different, you need to run all the configuration stacks. So while you are creating or configuring this server, you need to configure with fixed values. Like you wanted to use two CPUs or three CPU or like RAM, storage. Per VM, you have to decide that. And when you're booting the operating system or when you boot this server, it's 30 to 60 seconds of time it will minimum take to boot it. But the performance not that much, not that so good actually. Uh, it is it is not that easy. I have written these points and it is booted within 30 or 60 seconds. No, it is taking more time than this. This is an average time which is ideally recorded over the many articles because I was not there that time. I not seen this one. Who are having 10 or 15 years of experience over the Linux part or previously they are working on the middleware side, they would be having this clear picture in their mind. Okay. So that time I was doing my college or my schooling. So this is something mentioned over the article sites. Many of you, I mean, many of the experienced people are written and they're given report into the Google, and from there only I have collected and I'm telling you that. And this is real actually. And generation 2, so which is virtualization only from 2010 to 2013, no, from the 2008, you can say, from to the up to 2015, okay, not even 13, 15 up to that. You can say that generation 2, so which is VMware vSphere. Okay, still vSphere is being used in many companies. Many companies vSphere is being used to handle this bare metal servers. But still, there are some problems. Even you can say that dynamic memory, CPU heart added capabilities are there, but still there are some problems. What problems we are getting, sir? You're telling these many advantages, and that time these servers are present. That is a big thing. Again, what on top of that, what advantages we want? Yes, that time these servers are there, but it is creating high impact, right? High manual work. Engineer need to work a lot on the servers, a lot to maintain, a lot to uh, configure, or whenever he wanted to do patching or installing or deploying any application, lot of manual work is there. If something goes wrong and to fix that, it is taking days of time, not hours or minutes, taking days of time. 1 day, 2 day, 3 days. So days of time it is eating. So that time applications were down. People are not able to do any development because of the deployment problems. We don't know whether when the server will go off. The server will go down, then systems are down that time. You might be seen in 2012 or 2013 or something around, IRCTC or the government websites are getting down frequently. They're not able to handle the load that time. So whenever you wanted to register anything or you're going to government offices and government sites to make it an online or a bank thinks they'll keep on complaining that server is down. server is down like this. So that time it is these are the problems with the bare metal and on-premises servers. And the workloads which we have installed over the server was not that much reliable. And then this containerization technology came. So with the Docker is a tool. So if you see this diagram, let me increase. If you see this diagram, so this is Docker architecture and this is VM architecture. So both are looking similar, but there is only one line difference. One is when you take these two boxes as a server, hardware and hypervisor type 1, and then virtual machine 1, virtual machine 2, and virtual machine 3. So there is a concept called guest OS. What does it mean? Guest OS. Guest OS means already and in one server, you are running one operating system. Already in one server, you have base operating system already. Base OS already here is there. Okay. On top of this, again you have to install guest operating system. Okay. So this is your main server actually. Base operating system is there. On top of your guest operating system, and then you are running your applications. You need to manage both the operating system. This is your application. This is your application. Something like, let's say it is your Windows laptop and you have installed VMware application. On top of that, you pulled a Windows image or a Mac image, and then you have booted and it is running, right? Inside that, you are running one more application. So here you're maintaining two operating systems. You're worrying about two operating systems. So that is the problem with the virtual machines. And it is not that so easy maintaining this network. It's not that so easy of maintaining this network interfaces between your host operating system and the guest operating system. So there is a problem. It's not that frequent it will connect. There would be a problems and resource maintenance. You need to also consider CPU, memory, okay? CPU, memory. It can be over exhausted, okay? That time your application may go down. It's not. So if this server is not enough capable and you wanted to move this application to another server, is that easy? No, it is not easy. These are the problems with the physical servers, means with the virtual machines, physical servers, virtualization technology. So I'm giving in a very layman kind of things. If I talk in a very technical, then there'll be a lot of terminologies will be involved in this between. What is base and guest operating systems and all this here. Okay, we need to maintain this 1 GB of the storage. I was taking an example. 1 GB of the storage for the guest operating system, right? So my main server is having only 8 GB. My main server is having only 8 GB. So in this 8 GB, my operating system, my base operating system, which is there here, my base operating system is already eating 3 GB. It's already eating 3 GB. And how much left? 5 GB. So in this 5 GB, 1 GB is took by your file system, your logging, installation, dependencies and all. How much left? 4 GB is left. In this 4 GB, you are allocating 2 GB to your one of the guest operating system. One of the guest operating system here. Here you are allocating the 2 GB here. And how much left? More 2 GB is left. And this operating system, when you're running this application, it will also going to consume something more, right? And you cannot create another virtual machine here. You only have the 2 GB. If you also allocate to another one, and you are running this server is going to hang. It is not enough, right? So these are the resource constraints. So there are a lot of resource constraints are there. So that is the problem of maintaining this. So you need to again patch this operating system. You need to install the drivers. You need to maintain. You need to maintain networks. So these are the problems with the virtualization technology. That's why Docker is created a revolution and everyone is moved towards it. Let me tell you how it is more efficient. We are discussed about the lot of problems on this, right? Now, if I tell you about the Docker, let's say this is my, there is big thing, right? So Docker logo. If I take the Docker logo, let me take that. So this is Docker logo. If you see, as everyone's saying in the internet, I'm also saying the same. So this is a water, like ocean or a pond or a lake. Okay. So the ship is going on top of this water. This on the ship we have a containers, right? So these containers are holding different stuff. This container would be having bikes in it, and this container would have cloths in it, and this container will have scrap in it. Okay. This container will have cars, and this container will have some medicines or something like that. Okay, this container would have guns. On the ship, it is source to destination. This is a source and this is destination port. Okay, the ship is a medium that is carrying all these things, and the ship is having an engine. Okay, on top of this engine, it is carrying this load of the containers, and containers also having different stuff inside, right? Shoes, cloths, like this. Different thing, not only one thing. Different thing it is carrying. Means it is sharing the platform, right? Similar way, that's why this logo is given to the Docker because the same functionality it do. The same example we can take. Okay. So what happening if I take this server? So this is my main server. So this is my main server. In this main server, I would be having my base operating system. What is this? This is my base operating system, like Windows, Linux, Mac, whatever. On this base operating system, I'll install Docker. I'll install Docker. So this is Docker. So when you install the Docker, it will call as like you can call it as the ship engine. Okay. So we call it as a daemon. Okay. Or it will take this host network. It will create one network here. And on top of this, I can deploy containers. I can deploy containers. So this is a one container, which is Java container or a Java web app. Let's say Netflix. I'll create one more container, which is Prime. I'll create one more container, which is Hotstar. So three different applications I can run on the Docker by using containerization technology. Okay. Now this server is referring to the ship. The server also something like your ship only. Okay. On top of this engine, you are carrying different containers. Inside the container, different thing. This is a Hotstar code. So this is a Prime code. This is Netflix code. Single server I can run like this. Whereas if I go with the virtualization, if I go with the virtualization, base OS, and top of that, I need to install VMware Tech, and top of it, I need to maintain this one, which is guest operating system. I'm just telling us guest operating system. If I wanted to install two applications, and like this, here I have to run the application. This is Netflix and this is Prime. Like this. So you need to maintain this one and this one and this one. On top of this, you will run your application here in the server. And the server, you will run like this. The problem is this server is having one IP address, right? This server would be having one IP address like 1.1.1.1, something like that. When your user traffic is coming, it has to connect to your host network, to your virtual machine network with your operating system. And drivers should be installed up to date. There should be no problem. And when this application is getting more traffic, or whenever you are doing performance testing, or whenever you are doing UAT kind of testing on this Netflix, in this server, it should not go down. Should not go down. Example, uh, might be testers would be here. Any tester, when you are running testing on different browser stacks, right? You need to run this application testing over the Edge browser, Chrome browser, uh, Firefox, Mozilla, or Opera. You need to run over the Internet Explorer. Okay, there are 3, 4 browsers you need to run. So when you are running, that is your headache that you need to run and get the report and means analyzing it and writing the report. But behind the scene, where this browser should run in a one server, where in the company's network, there should be we have to deploy, right? We need to maintain, right? So how can I manage that? Not you. You are only not one who is going to use this platform. There are many testers out there. They would be using that. How this platform could be handled with this many different servers and different things. So if this server is utilized 100% memory and CPU, you cannot increase in minute. You cannot increase one more mission like this in just a minute or just a second. It's not possible. That is a problem with the virtualization. That's why Docker came and Docker is using. Now how simple it is. Here you're using 1 GB, at least 1 GB or 2 GB or 5 GB here. But at this container, it is just 500 MB. Maybe hardly 1 GB or 2 GB, 3 GB. Hardly. Okay, if it's a big application. But your virtual machine is not like that. Okay. So that is the problem actually while you're maintaining these things. So Docker will give you more uh, flexibility, and it will give you more uh, these things like uh, you can deploy applications easily on it. So these all things you will get it with the Docker on this. So if I wanted to move this container to other server, it is very easy for me. You just, I will be having one Docker image. With the Docker image, I'll move to other server. I'll simply create one more container over there. It's very simple. I no need to allocate any separate GB to this Docker system. The container will occupy some amount of GB from my space, from my server. So this is something which making more reliable, flexible, comfortable, less resource constraint means less resources it will be using and more compatible. So that's why Docker is highly advanced. It's having high advantages and every company is using this. And we need to also learn this. Without Docker knowledge, you would be a tester. You testers, if you are um, like if you're not a QA cum DevOps, no problem. If you are a QA cum DevOps means you have to know this. If you're not that guy, then you are only doing manual testing. It's no use for you. And if you are a DataOps guy, you must know about it. You are a developer, you must know about it. If you are an infrastructure guy, you must know about it. Even though you are a um, any application developer side also, you must know it. Docker is mandatory. For few guys, it is not mandatory because they won't touch this part, but others, everyone would be touching this part. So this is very important. As of now, is anyone having any doubt or everything is clear? Everything is clear. If you have any question, you can just raise your hand or you can keep a message in the chat. Yes, no, cool. Then we'll start with the fundamentals of the Docker. Let's say I have the server. So this is my server and this is my application code. This is my app code. Can't I run this app code directly into the server? Why do I go with the Docker? This is my server. Can't I run this directly into the server? Yes, we can. But what about the dependencies? Every time do you install dependencies dynamically? No. It's Are you always going to do everything in a manual mode? And conflicts of the versions, conflicts of the dependencies, and there would be a breakage. So many things will come into the picture while you are running directly into the server. And if you are running directly into one application into the one server, then that's it. You stick to this server. So there is no scalability. There is no availability. There is no that's so reliable. And single point of time, if you ask, that's so no reliable. So that's why we need to go for the containerization technology or a web server tools. Okay. Previously, there are some tools like Tomcat kind of thing, but now containerization is the best and the best. I have this code. However, this code will transform into different stages. So this code will build, and when it is built, the packages will be generated. Okay. So these packages I can deploy into server. That is something good actually with your Tomcat tool or with your Glassfish, JBoss, Wildfly, and some IBM tools also there. So with that Oracle, you can deploy these packages. So that is somewhat efficient, okay? But you want more efficient because the traffic is more and your maintenance is more and you are moving from legacy to microservices structure. So moving to the microservices structure, this is won't support. So containerization is the best thing to support on a microservices things, decoupling way. Here, once this package is generated, what I will be doing? We have to generate Docker image. What will be doing? We'll be doing Docker image. So this Docker image is combining these two things. These two things will be inside. It's a kind of a document. It's a blueprint. It's kind of a document. Everything will be inside this Docker image, like your dependencies, packages, everything, your application code. Those things will be into your document. That is the Docker image format. So this image, in order to generate this image, how you will be generating this image? By using Docker file. By using Docker file. So with this Docker file, we'll generate this Docker image. We'll generate this Docker image. And this Docker image, we run it as a container inside the server. Inside this server, we will run it as a container. We'll run it as a container inside this server. So this container, this code will run inside this container and the user can access this that time with IP address. And the user would be accessing this server with an IP address. And where this container will serve this application to this guy in this container. So this container also is nothing but a running virtual server only inside your main server. So this is important, but here lots of subject is involved of building this code, writing this Docker file, and generating this Docker image. Generating this Docker image. For that, we need to have one server, we need to install, and we need to run. And we need to know about the Docker file, how to write Docker file. In every interview, you will get this question, can you write a Docker file for me? Okay. So Docker file is important. Writing the Docker file, building the Docker image, scanning it. Okay. Here, the part called scanning. Okay. After scanning, it will go to successful scanning things into registry. From this registry, it will come back and run it as a container. So this scanning also important, this registry also important, and you're deploying the container also important into your server. So this is a Docker part. Writing Docker file will involve a lot of things. There is a conflict in interest, like should write this Docker file or a DevOps engineer should write a Docker file. Both are responsible, actually. Both are responsible, but who is going to write this? In initial stages, when the repository is created by a developer means developer should write this Docker file, not you. If it is having some failures or not able to manage, then you are the person to fix the Docker file. Because the code is written by the developer in initial stages at his local environment and he wanted to convert that code into the containerization, then he is the person should write the Docker file. If he won't write it, then you should write. He should ask you, then you should write. If he written, but he is not able to execute properly, get an errors, then you are the person to fix it. And you are the person to help him. Okay. So these are all the some things that we need to know while you're working in your company. Docker file. So it's a big subject, writing of the Docker file. So how this Docker architecture will work? If you go to our notes, I have already mentioned how this Docker things will be working, but let me also explain you how the Docker will work. Let's say this is Docker. And you have laptop. Let me take the laptop image. Have laptop. So from this laptop, so there would be a client, okay? So this is you can call to client, Docker client. And this is something called Docker daemon or something like that. Docker engine, Docker daemon. And there is a registry, Docker registry. And you would be having the environments like this. You can see here, test environment, staging environment, production environment, and all this. So if I have this environment, what happened whenever I wanted to communicate, so with my Docker, I need to run a command Docker first, then only to understand this guy is talking with me. Docker. I need to keep this in the server. Docker pull image and image ID or image name. Then what happens? This client, when I'm running this command, it will understand by this daemon, and there are components like registry, container and images, things are there inside. What? Images, containers, registry, networks, volumes. So these things are there. So Docker daemon will understand the structure. Okay. So what this guy is calling in the components present inside me. If I'm calling image, then it understand oh image. Container, then it understand container. Network, volume, what this guy is telling to me. So what I said, Docker pull image. So where I will keep the image? In registry. In registry, I will keep the images. Why? This is a storage. This is a storage. Like your GitHub. Okay. Docker registry. So don't think it is a GitHub. I'm just comparing with GitHub. It is something like that. So you have ECR, ACR, GCR, JFrog, okay, Nexus, and you can even not just three. Docker Hub. You can use these things as a registry where you can keep the images. Where you can keep the images inside. The image will be present inside the server and as well as at the registry as well. So here, let's say this is my image. This is my Docker image. It is present here as well and it will present here as well. So I can delete or keep here. It's my wish in this server. But this is your backup. This is your backup. That's why we call it as an artifact. This is our backup. We are keeping in the registry. So whenever I want, I can pull here. I can use this image. I can pull as many times as I want. So this is my backup. This is my backup. So this is something at the local in the server. I can keep, I delete or whatever I can do. So this is how this Docker architecture will work. You have a CLI where you say the commands. It will communicate with your daemon where it is means engine Docker engine things. Okay. So where it is having a multiple components, it will be connected and then it will be. If you also search Docker architecture, you will get the good images. You can see here Docker build, Docker pull, Docker run, Docker daemon, containers, image and registry. Okay. So whenever you install Docker in this server, whenever you install Docker in this server, then this is called as a Docker host. Okay. So this is a basic thing, architecture explanation. In order to practice, we just need to install the Docker. That's it. If you install the Docker, it will work. What platforms we have to play with Docker? You can go to the Google and ask play with Docker. So play with Docker. Click on this. Log in with your GitHub or Docker Hub ID. Okay. Log in with your GitHub or the Gmail. And then it is going to ask you start. It immediately create a server for you from the Google. You're using Google free session. But they are saying we are really sorry, but we are out of capacity, can't create your session at the moment. Please try again because many people are using it. If this is not works for me, then there is another one is called Killer Coda. search this killer coda. Click on this and log in with your Gmail address. And here you can see playgrounds. Click on this playgrounds. And here click on the playground. Select which one you want. I want Ubuntu 24.0 LTS, okay? Single node Ubuntu environment. Click on this and click on start and move like this. Increase your thing. Okay. Docker. If I say ls, I'm normal communication with the server. If I say pwd, normal communication with the server. But when I say docker hyphen version, I'm communicating with the Docker, right? The Docker version is 28.2.2 is there now. So Docker images, anything is there? No. Docker PS containers, any container is there? No. Now what happened? The client commands or communicating with the Docker daemon, and daemon is responding on what component it know and what you are asking in this server. If you take normal EC2 instance also, you install apt install docker. That's it. So previously, many people are used to install client and server, but no need. Once you install Docker, it will come up with both the things in the server. I don't have anything right now, but I wanted to create one application. I want to create one application. Which application? So go to the Google, search static websites download. So there are many static websites are there, but I don't. Whether it is downloadable or not. Giving copy link. Copy link. Come to your environment. Wget paste. No, it's not coming. Let's do one file. Web app.html. Let's go to the Google. Hood order, web app, HTML code, data. So there is something, some HTML code is given here. Let's copy this, come here, paste this. Now I have saved this, okay? I wanted to build this, my application as a Docker container. How can I do it? Simple. You just go to Docker. I'm just showing you, okay? Go to Docker Hub. Docker Hub. It is my registry where I have multiple images. Those images I can take and I can take them, I can build. Now I wanted to build with Apache HTTPD. Okay, HTTPD. If I search HTTPD, so I would be getting multiple images here. These are the runtime images. These are the base images where my application will run inside. So you won't get now. Just hold for some time, means 2-3 classes. From tomorrow we go all this practice. I'm just showing you how it will look like. So this is the image I wanted my application to run inside. If you come down, so there is the thing called Docker file. Okay, everything is here already. Just come here, go here and write a Docker file. You can name it anything actually. Docker file name, can name it anything. And here I wanted to remove this because I'm not specifying any directory. So all the current things can be copied into this htdocs. HTTPD from, I'll tell you what is this Docker file. Just see what I'm doing. I have saved it and I wanted to generate a Docker image. Like just before I said, I wanted to generate this Docker image. How? Docker build -t. These are something command. I would like to build this application -t my app dot. So it is building the Docker image for me now. It is pulling this image from the Docker hub and it is downloaded completed and then it will copy my code into this HTTP image and then it will run. You can see here copy successfully built, successfully tagged, successfully built and successfully tagged. And then I can say Docker run. I would like to run it as a container. Before I'm running it as a container, I want to see image. There is my app image is there. How much MB it is? 117 MB. How much MB it is? 117 MB. But in your virtualization case, no, it is not 117 MB. It will go and take 1 or 2 GB like that. It is just 117 MB here. Okay. So now I would like to run it as a container. Docker run -p and I wanted to export on a particular port number 8080:80 my app. My app is the my image. Couldn't determine fully qualified domain using -itd -p. Docker PS. This is running, you can see now. This is running now. How can I see this? Right side here, traffic ports. See 8080. When you click on 8080, it is telling that it works. But inside this path slash index.html, web.html, right? Web app.html. See, my app is open. My food order app. Pizza. Add to cart. Added cart. So very basic HTML code we took it from the online. Now I'm able to deploy it. If my developer done the same thing, whatever the code it is, I don't care. He done in Python or he done in Node.js, he done in Angular, he done in whatever. For DevOps, not a matter. Whatever the developer is, we need to execute Docker file properly and then run it as a container. Then that's it. Boom. The container will open in an application. If this application is connecting to the storage database and we should only responsible for them, they are connecting properly or not. If they are connected, then application will work perfectly. If those things are not connected, then it is our responsibility to fix it. We're not dealing with any coding here. We don't know also. We don't want also. It's a developer headache. We need to know these operations. We need to know these works, how I'm developing this, how I'm doing this, where should I place this, how can I run it, is there any issues while it is running. So this is where our skill, expertise, and our mind will work. Coding can be done at the local environment only in the laptop. Developer use it to say one parity words like what? There is a syndrome for the developers. What syndrome? Hey, it is working perfectly in my local system. Why it is not working in the server? There's a lot of difference, Muddy. Lot of difference in between two things. Working in local system is different. Working at the server level it is different. Working at your local system, you might have a local DB or you are connected your local system to the your main DB in your company network with a VPN. Okay, you just hosted over their local host because all the dependencies, configurations, everything is there. If you're using Copilot, everything it will install for you. It will suggest for you. But it is not the same thing on server side, right? At environment side, it's a big infra. So every engineer will get this word from the developers over the call. It is working in my local system perfectly. Why it is not working? So we need to understand all this. Uh, I'll be going to cover more deep from tomorrow onwards. I think I already given my, like I spoke a lot of things. So if you're not able to catch, let me know where you're not able to catch me so that I'll repeat again in a better way. So please don't hesitate to ask. Ask me. You just raise your hand, then I'll give you unmute option. All good? Okay.
Yeah, hey, Rajini, can you hear me?
Yes.
Yeah, I have a couple of questions. So you said like somewhere microservices in the Docker, right? I mean, what are the
Hmm.
microservices that we use in Docker? That is number one. And number two question is like how often should Docker image be scanned like
Mm-hmm.
every run, or is it for a one time like during deployment? That is my second question. And then the
Mm-hmm.
third question, you were talking about the API, right? So when you
Mm.
deploy from one environment to another environment, you said that it's a developer a task to maintain all these API keys, right? So do we do that in Docker or
Good question.
yeah?
So let's say this is you and you are a developer. You have a laptop with you. You've done all the code, and then it is you're merging to the GitHub. So from this GitHub, the pipeline will start. So this is your pipeline. So in this pipeline, so there is a one stage which is Docker build stage. So this is Docker build stage, where it use the Docker file and it will generate one image. And every time this pipeline is running and generating new image, that will be scanned. The each run that you do and each image that you are generating, and it will be scanned. So that is the thing. And then every time successful scanned images will push into your registry. And unsuccessful also will maintain somewhere, okay? Registry, like this here. And then you have two ways to pull up, okay? And then you're deploying here. So this is your container. In your repository, in your organization, you will be having all these things, right? Like let's say any company you take, Flipkart or in payments, orders, search, user, accounts, cart. You're seeing, right? This all things. Let me go to Flipkart or Myntra. Why my pen is not open? Yeah. So here if you see, here I have this become seller, cart, login, this search, this product gallery. Okay. So all these are microservices. So this is one microservice. This is one microservice. This is one microservice. This is one microservice. These are all decoupled. When developer is doing some update on the become seller thing, cart won't affect. No need to make down the cart. No need to make down the login pages. People will log in, people will cart. Okay. Become seller can be updated in your deployment. So decoupled. It is not tightly coupled. Tightly coupled, decoupled. What is microservice and monolithic structure? If you ask me that question, microservice and monolithic is something like your Windows and Linux. So this is my Windows machine, let's say. There is some update came. Everyone is using Windows, right? There is some update came. When update came, it has to reflect like your network driver or a driver should be updated. In your settings when you went, it is said that it has to update it. When you are updating that, it won't reflect in your system. In order to reflect in your system, you need to restart the system. But you are doing some work in the notepad. Okay, you are doing some work in the notepad. Without disturbing your notepad work, will you do restart of your system? The particular thing, whatever you updated. Will it happen? No, it won't happen. You have to disturb everything on your Windows system and then you have to restart. Whatever the work is there in your notepad, it could be stashed, means stored temporarily, stashed. Then you can rework. But there is some break, right? A system is getting down and then booting. So that is monolithic. We call it tightly coupled. Everything is coupled. One to another is dependent. Everything is in one box. Microservices means no connection, but they work all together. So that is microservice, like Linux. In Linux, you can restart one service separately without disturbing other things. So that is microservice. Okay. And here, similar way, we have payments, orders, search, user, accounts, and cart. These are all microservices. Each one will have a separate repository. This is one repository. This is one repository. This is one repository. And this is one repository. And this is one repository. Like this. And each one will have the separate CI/CD file. Each one will have Docker image. Each one is going to run as container. It is going to run as container. So this container you are running here. Each repository running each container. We're dealing this container in the Kubernetes as a container. For this container, how much traffic is receiving? That we need to calculate. See, how many people are going and doing cart? Cart is running here. So order also running there. Cart is also running there. So if my developer did some updates in the orders and people are who are doing cart and payments, they can do. Because of orders, my developer is done something and I'm deploying. Will payments and other things will be affected? No. Orders can be deployed without disturbing other services. So that is microservices that we can maintain in the Kubernetes as a containerization technology. We are only dealing this part. And this payments to orders, orders to search, search to users. So there are communications between these microservices. There is a communications with your API, with your queuing systems. Okay. There will be communication between these things. So that we will be discussing over the projects. And coming to your secret maintenance or API keys, something like that. So that will be as a security operations again. Okay. So you have to everywhere not to hard code. You have to uh, keep it securely by using variables or any vault. Then, but your container will be connected to it. I hope I clear your question.
Yeah, Rajani, yeah, thanks. Yeah.
Cool. Anyone having any questions still? If not, then we can conclude the session. It's already 8:30 now. Cool then. So no questions. Then thank you all. We'll meet in the next class.